In the last lesson, we introduced the polynomial. In truth, it wasn't our first time seeing one. We have been working with them ever since we worked with equations with more than one term. However, now we have a greater ability of manipulating and experiencing these because of our formal recognition of a polynomial. Although addition and subtraction may seem foundational to our work with polynomials, we actually need one more operation to greater enhance our understanding of the science behind them. That is, multiplication. We'll be spending a good while on the technique of multiplication of polynomials, because they are not only many, but also very powerful and useful in algebra, and even more so in calculus. Since these techniques are so important, I will give each one their own lesson. This first lesson will deal with direct multiplication of polynomials, such as 3x minus 4 times 2x plus 1. If we remember our rule about numbers separated by parentheses, we know that entails multiplication is a must. For example, 3 times 2 equals 6. But we're not working with single numbers. We have two separate polynomials being multiplied. This lesson will require us to remember the distributive property of multiplication. We remember that a times b plus c equals a times b plus a times c. We use the very same idea here. Let's imagine that the 3x minus 4 is our a variable. We'll then multiply our a variable to each of the terms in the second polynomial. So we have a times 2x plus a times 1. Now we'll unravel the a, which gives us 3x minus 4 times 2x plus 3x minus 4 times 1. Notice now that after we used the distribution property on our self-defined a variable, we have two more instances of the distribution property. Simplifying these will give us 6x squared minus 8x plus 3x minus 4, which simplifies to 6x squared minus 5x minus 4. We have successfully multiplied two polynomials. Before moving on and showing the real meat of this lesson, let's practice a few more examples. Number 1, 4x minus 5 times x squared plus 7x plus 1. Notice we have a binomial and a trinomial being multiplied. We can multiply any number of terms together using the distribution method we learned. If we let a equal 4x minus 5, we can just multiply the a to each of the terms in the trinomial. This gives us ax squared plus a7x plus a1. Unraveling a will give us 4x minus 5 x squared plus 4x minus 5 times 7x plus 4x minus 5, which simplifies to 4x cubed minus 5x squared plus 28x squared minus 35x plus 4x minus 5. Simplifying even further, we are left with 4x cubed plus 23x squared minus 31x minus 5. Number 2, 2x plus y minus 1 times x plus 2y plus 1. Now we have two trinomials being multiplied together. We can still use the same technique here. Letting a equals 2x plus y minus 1, we have ax plus a2y plus a1. Unraveling this gives us 2x plus y minus 1 times x plus 2x plus y minus 1 times 2y plus 2x plus y minus 1. Once again, we're left with simply using the distribution property. We get 2x squared plus xy minus 1 plus 4xy plus 2y squared minus 2y plus 2x plus y minus 1. Simplifying this, we get 2x squared plus 5xy plus 5, that's supposed to be x, plus x plus 2y squared minus y minus 1. Notice that when expanding expressions containing more than one variable, it quickly becomes lengthier. Number 3, a plus b times c plus d. Here we have just 4 variables that represent numbers. If we let x equal a plus b, we can then write out xc plus xd. Unraveling x gives us a plus b times c plus a plus b times d, which equals ac plus ab plus ad plus bd. You might be tempted to think that this was a lot of work just to multiply two polynomials. And you're right. Because of this, mathematicians have come up with tricks that help us to simplify these much more efficiently. This first trick or technique is called the FOIL method, and that's what we'll spend the rest of this lesson looking at. The FOIL method is a technique that helps us to simplify two binomials that are being multiplied together. Using our previous demonstration, 3x minus 4 times 2x plus 1, I'll demonstrate how efficient this new technique is. The first thing to know that it is called FOIL because it is a mnemonic. FOIL stands for something. That something is first, outer, inner, and last. FOIL. FOIL. It is a set of instructions that tells us what to multiply and when. Think of the two binomials. First, we multiply the first two terms, a and c, the outer two terms, a and d, the inner two terms, b and c, and finally we multiply the last two terms, b and d. We then add or subtract the outer and inner terms since they usually will be like terms, and we're done. Instead of treating the first binomial as a single variable and multiplying it across, we actually utilize the distribution property for each term, giving us the same answer as previously done. Using our previous demonstration, we have the first two terms, 3x times 2x is 6x squared. Then we have the outer terms, 3x times 1 is 3x. We have the inner two terms, negative 4 times 2x is negative 8x. And then we have the final or last terms, negative 4 times 1 is negative 4. Adding the middle terms, we have 6x squared minus 5x minus 4, which is the same answer we previously had. Now we'll work a few examples to illustrate FOIL. Number 1, 5x minus 3 times 5x minus 8. We start by identifying the first, outer, inner, and last, and then proceed to multiply. We have 25x squared minus 40x minus 15x plus 24. And this simplifies to 25x squared minus 55x plus 24. Number 2, y plus 5 times y plus 3. These are some of the most simplest because the leading terms have no coefficients. we should get y squared plus 3y plus 5y plus 15, which simplifies to y squared plus 8y plus 15. Number 3, 3x plus 4y times 6x minus 2y. Finally, we have one with coefficients and different variables in each term. Just take it slowly, being careful not to lose any signs, and we'll get the right answer. FOIL will give us 18x squared minus 6xy plus 24xy minus 8y squared, which simplified gives us 18x squared minus 18xy. That is supposed to be a xy, not an x squared. I don't know why I did that. Minus 8y squared. In the next lesson, we'll take a quick look at a couple of special cases that are even more efficient than the FOIL method. Special product formulas.